Okay, 1-9 inverse functions. You started seeing inverse functions in Algebra 1. You didn't do a whole lot with them, and the concept was very vague in Algebra 1. Okay? Last year in Algebra 2, we actually did everything you're going to do today. All Chapter 1 is, in this book, is a review of Algebra 2, because they're things we keep bringing up and keep bringing up. So we're just going to keep working with those.
No.
Okay, so two functions are inverses of each other if and only if f of f inverse, remember that -1 means inverse, f of n inverse equals x, and f inverse of f of x equals x. So you have to do the g of f and the f of g, basically. They both have to come out with the answer of x, nothing else. It can't be -x, it can't be 2x, it has to be what? X. Now, obviously, if the variable is t, it comes out with a t. The domain of f is equal to the range of the inverse. Remember, I always sit there and go like this, right? They swap domains and ranges. That's what this visual is. The domain of f is the range of f inverse. The domain of f inverse is the range of f of x. They just swap those. They physically, the x's and y's are changed. So if in f it's 2, 1, f inverse is going to be 1, 2. The reflection across that y equals x line, actually, I always do the opposite way. Y equals x line, that's what happens.
Okay.
No date.
Lena, you let me know when you're ready.
You're good.
The other people are writing too. Brad, you good? Awesome, good. Everybody's like, it's a race. Everyone good? Okay. So, which of these functions are inverses of 5 over x minus 2? So I just told you back here. Go back.
You're going forward.
I understand that. I'm not clicking forward. Okay, I just said we had to do f of f inverse and f inverse of f, right? So I have to do the composite to check that. So, which one do you want to start with? The g of x or h of x?
G.
G? Okay. So when I do this, so let's see, we're going to do f of g of x. So we're going to put this whole thing in for that x right there, right? Is that what this says?
In my
So 5 over x, but x is now x minus 2 over 5. Minus 2. We got some work to do.
Holy cow.
No, what is f? Shh. F of g of x. What is g of x? This whole thing, yes? So it has to go in for that x, doesn't it?
Oh.
And that's what I did. Okay, so now we got some work to do on it. It's not too bad. Now, the numerator is good. Remember when we had these, we simplified the numerator, then we had to simplify the denominator, and then we had to multiply by the reciprocal, correct?
Yes.
So numerator is good. We don't need to do anything with it. The denominator, we need to get common denominators, which is going to be what? 5. So this is going to be minus 10 over 5, correct?
Yeah.
Okay, so I'm just going to change this to a 10 over 5. Well, -2 minus 10 is what?
-12.
-12 over 5. Okay, so I'm going to make this bigger. So the numerator simplified. Is the denominator all one thing?
Yeah.
Yes, it's all one fraction now. I'm ready to multiply by what?
Multiply by 5.
Multiply by the reciprocal. So I have 5 times 5 over x minus 12. Yes?
Yeah.
So you get 10 over x minus 12. Well, if this was inverse, what should I end with?
Would it be 25 over x minus?
Oh, it would be 25, yes. Either way, the answer is what?
Not.
No, because what is it supposed to end with if it's the inverse? Just what? X. Just x. Did we get just x?
No.
No, let's make sure we did it right. I'm pretty sure we did. So minus 2 would be 10, and 2 minus 10 is 12. And nope, if the 5 was in the numerator, that'd be great because then the 5s would reduce, but I still would have x minus 12. So is g of x even possibly the inverse of f of x?
It is not.
No. Now, I could do g of f of x, but they both have to come out to be x. So I can stop, right?
Yeah.
Okay, so we're going to try f.
F of H.
We're going to do f of h of x. So we have 5 over 5 over x plus 2 minus 2. Correct? Because I put this whole thing in for what? That x. Okay, so I'm going to erase this now. So it gets... Well, this is nice because the plus 2 minus 2 in the denominator, what? 0 out. So I have 5 over x. So now I multiply by the reciprocal. So I have 5 times x over 5, which reduces to just what? X. So that way worked. So now I have to do what? H of f of x. I have to show both. Because it has to be commutative. We know, just a second, we know composite functions are not always commutative, right?
Yeah.
So if they're inverses, we're going to end up with the same thing both times. Yes?
Why did you flip the x and the 5 for it?
Because we have to multiply by, right here, we're at this stage, you have to multiply by the reciprocal because we have a division of fractions. Okay?
So now it's going to be 5.
So now it's going to be 5 over x, but what's our new x?
X minus 2.
No, 5 over x minus 2. It's the whole thing. And then plus 2?
Yes.
Okay, so myself personally, I'm going to leave that plus 2 hang out there. Let's just deal with this because this is all ready to go, isn't it?
Yeah.
Okay, instead of getting that'd be a weird common denominator to do. We could do it, but would that be weird? Yeah. So right there, I'm just going to multiply by the reciprocal. Yes? So I'm going to 5 times x minus 2 over 5
Yeah. The
plus 2.
5's are reduced.
5 was reduced out, and so I have x minus 2 plus 2, which
So you just
reduces
need
to
X.
x. So did I both get x's both times?
Yes.
Yes. So h
Of H.
h of x is f inverse of x. Yes?
Yes.
And I had to show this commutative property that only happens on composite functions when they're inverses of each other.
It must be h of x.
H of x, yes. That's an x. Doesn't it look like an x to you?
No, it looks
Not
like
for
a
us,
Z.
then.
Once you know it's an x, right? Am I good?
Yeah.
Okay. So now, show that f and g are inverses of each other. Okay? Algebraically and graphically. Whoa. Okay. Well, algebraically, we got to do f. Yep.
Answer's yes.
I have to do f of g. Yes?
Yeah.
Okay, you guys do that real quick. And then after you do f of g of x, then I want you to do g of f of x.
Okay, so this is not as bad as the last one.
Yep. Yeah, this one isn't even as bad as this is. No. Inverses will typically have fractions in them at some point, but you notice how when I had the fractions when they were inverses, did they just kind of melt away?
Yeah.
Yeah, the first one, it just kept getting more complicated. The second one, when they were inverses, kind of just falls apart. If it's not falling apart, you probably did something wrong or they are not inverses.
You can kind of tell it inverse just by looking at it.
Yeah.
Right, but you have to verify it algebraically.
There you go.
Yes, you do. Well, in this case, I don't need parentheses because, well, I can, but they don't have to be there, do they?
Well, technically, you're not like.
I'm not distributing a negative or anything, so. So are they inverses of each other?
Yes.
Yes, algebraically.
Yes.
Okay, graphically,
No.
Okay, for graphically this to happen, they have to reflect across.
The x-axis.
No, this the y equals x. The parent function, that was not supposed to happen, and now everything is gone.
Yes.
I'm going to redraw that. You guys got the inverse checked, didn't you?
I didn't get the bottom when you put F in the, never mind.
Just do it real quick.
There's really
No, yeah, just do it real quick. You got it, Garrett? 4. Sorry. On this, with this program, as soon as it switches slides, it like deletes everything you just did. Did you get it?
Yeah.
Okay. So we need it to reflect across this line, correct?
Yeah.
So, let's see, blue. Well, this one has a y-intercept of -5, yes? And a slope of 1.
Yeah.
And so that means let's see, the x-intercept would be +5.
Yeah,
How did I find that? How did I find the x-intercept? Set
because.
y equal to 0, didn't I?
Yeah.
Oops. It does go up 1 over own, but I also just set the x-intercept, or the y equal to 0.
Okay, but just up one.
Okay? Good there?
The other one's 5.
The other one's 5.
So the.
And then the x-intercept would be -5.
Yeah.
Are those a reflection across that line?
Yes.
Yes, most of them cross at some intersection, correct?
Yeah.
But our slopes are the same and they're linear, and anytime your slopes are the same and they're linear, what kind of lines are they to each other? Parallel. So are they going to ever touch? No. So this is kind of a different one. Most of them you'll see cross that XY line and have a point of intersection, but we can't have a point of intersection when we're parallel, can we? Okay. So there's a lot here. Do not write everything down. Hopefully you can figure out what you do need to write down.
Yes.
Does a function have an inverse? That's the question. Every function has an inverse. We've discussed that. It's whether they have an inverse function. Okay? Does that make sense? Every function has an inverse. The big question is that inverse a function? The answer is yes if. First, it's a function. It passes what test for a function? Vertical line test, yes? Then, does it pass the horizontal line test? And on that sheet where we had parent functions, we talked about that and we called it 1-to-1. Yes? Okay, if an equation passes both the vertical and horizontal line test, it is called a 1-to-1 function, meaning that every domain, or x value, has exactly one range, or y value, and every range value has exactly one y value. For every x, there's one y. For every y, there is what? One x.
That's not what you said, okay.
Okay? What?
That's not what you said, but okay.
Yeah, it is.
No, you said y and y on the very end.
Oh, I said y and y, but it says
Oh, she
y.
meant
Okay.
Y.
So if you want to shorten that last one up, again, for every y, there is how many x's?
1.
1. For every x, there's how many y's? 1. Guys, either you put your chairs down or you can stand up. Okay, so if it is 1-to-1, that means its inverse is also a what?
Function.
Function. Okay, functions are, when we say there's a function, when somebody writes f of x on a piece of paper, you should automatically know it is going to pass the vertical line test. Yes?
Yes.
If it says it is a 1-to-1 function, that means it has to pass what? Vertical and horizontal. So if you were to graph it and it wouldn't pass those two things, did you do something wrong?
Yes.
Yes. From here on out, if somebody says it's a 1-to-1 function, in your brain, you should know it passes what two things?
Vertical and horizontal.
Vertical and horizontal, and meaning its inverse is also a function. Carly, let me know when you're good.
So much fun.
Is some of this coming back?
Nope.
No. Yeah.
I just said yes.
For the first time, I might
Bring
have
on
to
you
say
can
yes.
go.
Are good? Okay. So, are these functions and are they 1-to-1? So, first one, is it a function?
Yes.
Yes. Is its inverse a function?
No.
No, because it does not pass the horizontal line test, correct? Okay. Its inverse actually looks like this. And does that pass the vertical line test? No.
Because it passes through both lines.
Right. Okay, so next one. Is it a function? Yes. Does it pass? Is it 1-to-1?
Yes.
Yes. So its inverse is a function. And it looks like, let me see if I can draw it.
Oh, it's a horrible thing.
Don't be mean, Evan.
1, 1. 1, 1 is going to stay there. And this is 0, -1, right? So -1, 0. It's the twist that's bothering me. It's going to come up like... And this is what? 2 1/2, so 2 1/2. There we go. This one's going to look weird, but they cross that line. Yeah, see.
That's not what it looks like.
If I wanted better, I'd do a what? X, Y, and I'd plug points into here and then just change them, wouldn't I?
Yeah.
Okay. Okay, so this, you don't need to write this down, you just need to look at it. If we were to sketch a graph, it reflects across that XY line, correct? The last two were parallel, so they didn't touch. These two are not parallel. I have 1/2 and I have 1 and I have 2. Those are obviously not parallel, are they?
No, they're not.
So if I graphed f of x, that's the dark. Nope, sorry, that's f inverse. That's weird. Okay, so f inverse is the dark. F is the lighter. And if you look at your points, on f it was 2, 1. So on f inverse it is what?
1, 2.
1, 2. 3, 3 is still what?
3, 3.
3, 3. -3, 0 is 0, -3. Can I go from f inverse to f?
Yeah.
Yes. Then, guys, they're inverses of each other. So it doesn't matter which way you look at it.
Stand up.
Okay. Everybody writing? Okay, there's another, just a picture. See how it doesn't cross up to the right, it crosses where? To the left? Okay. Now, where it crosses should always be, if it's going to touch, it should be on that XY line, because what happens on every point on the XY line? The X is the same as the what? Y. So if they intersect, where is it going to happen? On the XY line. Okay, so these are just basically, in order to find an inverse, we haven't done it yet today, but if the domain and range on inverses interchange, isn't that probably how we find the equation?
Yeah.
Yes. So to find an inverse, you interchange the x and y values, the domain and range, and you solve for y. And then you check your answer. How do you check your answer? F of g and g of f, right?
Yeah.
Saying f of f inverse is a full mouth, isn't it?
What?
Now, you do not have to always check. What?
Brad asked you.
I'm sorry, Brad, what? Yeah. So you have f inverse of f. Check them. Take the time. If you do it, are you going to get better with dealing with fractions, dealing with multiplying by the reciprocal? Is it going to help you in general? Yes. Did it take very long? No. If you've done it right, they should fall apart fairly easily.